Hi friends, welcome you all to my channel. Myself Edukanth and we are covering CBSE NCERT syllabus for 10th standard students. So in this video, triangles, very interesting chapter, important chapters, chapter 6. So in this video from NCERT Solutions, exercise 6.2, question number 5 and 6 and previous questions already I have done. You can see the links in the description. Right? The fifth question is in the figure DE, right? D in the figure, the triangle in the figure DE parallel OQ and DF parallel OR. So show that EF, right? EF parallel QR. So we have to prove that EF is parallel to QR. So very simple. From this triangle, okay, in this triangle there are three more triangles, right? Left hand side one triangle, right hand side one triangle, bottom one triangle is there. So we'll take left hand side triangle, that PQO, right? PQO. So in the triangle PQO, DE parallel DE, right? DE parallel OQ. Okay, by using basic proportional theorem. So according to this theorem, PD upon DO, PD upon DO, PE upon EQ. So this is equation number 1. Okay, we are taking the right hand side triangle, POR, right? POR. We are taking the right hand side triangle where DF parallel OR. So we are using basic proportionality theorem. So PD upon DO, PF upon PF, PF upon FR, right? So we have, this is equation number 2. We have two equations. From these two equations, we have PD upon DO, PD upon DO is common. Therefore, from equation 1 and 2, P upon EQ, PF upon FR is equal. From equation 1 and 2, we get P upon EQ, P upon EQ equal to PF upon FR. Therefore, by converse of basic proportionality theorem, EF parallel QR. So, according to converse of basic proportionality theorem, if a line, okay, simply there is a line, if a line divides two sides of triangle in the same proportion, right? If a line is drawn, this line divides the two sides of the triangle in same proportion, then this line must be parallel to the third line. So that is converse of basic proportionality theorem. So by converse of basic proportionality theorem, we have proved EF parallel QR. This is what we have to prove and we have done. So very simple sum using basic proportionality theorem and the converse of basic proportionality theorem. So shall we move on to next sum. So in the figure, here also a figure is given. So this is the sum. In the figure ABC or points on OP, OQ, R, right? So ABC or ABC are the points on OP, OQ, OR. So right, respectively is such that, right, AB parallel PQ. So these two lines are parallel. Same way AC parallel PR. Sorry, AC parallel PR. Show that BC parallel QR. So this we have to prove. This BC parallel to QR. Already given AB parallel to PQ, AC parallel PR. You prove that BC also parallel to QR. So very simple, right? So we are taking the triangle, this triangle OPQ, right? OP, we are taking this triangle OP, right? Yeah, this triangle, the shadow triangle OPQ. So where AB parallel PQ. So using basic proportionality theorem, so OA upon AP, OB upon BQ. So this is equation 1, right? So and then we are taking the next triangle, this side triangle, where these two lines are parallel. Therefore, according to basic proportionality theorem, OA upon AP equal to OC upon CR. So the proportion is OA upon AP equal to OC upon CR. So this is equation 2. So from equation 1 and 2, what we have, OA upon AP is in common. Therefore, OB upon PQ, OC upon CR are equal proportions. So OB upon PQ equal to OC upon CR. So right, So therefore by converse of basic proportionality theorem, just like previous sum, this line is dividing, like BC line is dividing this two sides in same proportion. So this line is dividing this two sides of the triangle in the same proportion. Therefore this line is parallel to QR. So that is the converse of basic proportionality theorem, and we have done this. So that's all, very simple. Thank you so much for watching this video, and let's meet you all in another video. Thank you so much.